All right, so let's get started. Shut up. So hopefully everybody, I'm guessing not though, saw my post this morning on Slack. We did have a tech talk last night from one of our former students. She graduated last May with her bachelor's and master's degree. She was our very first computer science scholar student. Who does a bachelor's and master's at the same time in 4 years. She's living out in San Francisco working as a software engineer for Major League Baseball. And she gave a tech talk last night. I put the recording up, but we had a very, very, very sparse turnout, which, isn't good because we've had, tech talk speakers, especially the ones who have to travel here. Zoom's less of a big deal, I guess, but the ones who travel here, if we have 5 students that show up, maybe they're not going to make that trip again, right? And these are people that hire our students. Similarly, we had a hackathon over the weekend that was advertised quite a bit, and we didn't have a very good turnout in that either. And that was hosted by Aurora WDC from Madison, business analytics company that also hires a lot of our students. And they sponsored it and had the prizes and all that stuff. So again, they drove an hour and a half and sponsored this thing, and we had 12 students who competed in it. So that, again, these are opportunities that are put in front of you, you're not taking advantage of. And I think I said it like the first week of class, 90% of what you're going to learn, you're not going to learn in the classroom. Classroom is just going to give you some framework for how to learn, right? And ultimately make you go through enough hoops to get a degree in the end. Unless you put yourself in real life situations where you get some experience or hear about other people's experiences or whatever, you're really not adding a whole lot of value to your expensive tuition dollars, because college is not cheap. So try to keep that in mind when you see those opportunities. It's relatively speaking, not that real life doesn't sometimes legitimately get in the way, but relatively speaking, I can't imagine that there wouldn't be several of these events that you could make it to by, skipping an hour of video games, or, maybe making a plan to work on your homework a little bit longer the previous day to set aside the 1 hour or something like that for a tech talk. Or I know giving up your Saturday kind of sucks, but, maybe you decide it's worth it. Because you get to meet the person that might be paying you money for your internship and then paying you $80,000 a year right out of school. Maybe that's worth it, right? But so try to keep those things in mind. This isn't the first time we had actually, it's pretty common now that we have no shows. I used to require things like the hackathons and tech talks and stuff like that for my classes. And then we had great turnouts, right? Because you had to do it for your homework, and, students would complain saying, well, I had work or whatever. Well, so I'd give an alternate assignment in case real life really got in the way. So you could do something else. But I don't know. I feel like I shouldn't have to bribe you to go do things that are kind of good for your career. So, if you want to not take advantage of it, that's fine. But something to keep in mind. But I did put on the Slack, my favorite quote that Emily used was best way to prepare for her tech interviews at Major League Baseball was basically Littman homework, is what she said. But now you're telling me I'm making my homework too easy. 6 hours on your homework, it's it? Well, you probably had plenty of time to sleep in and stuff, and it's just garbage.
Well, at least I finished it.
All right. Well, let's find out what the homework was. let's go down that route. All right. Oh, and I also noticed last night that the grades for exams hadn't been released, because they don't get released until all attempts have been graded. And there was one student who didn't do the exam. So until I went and put in a 0, it didn't show you all the grades. So sorry about that. I think the class average in here was, I want to say like a 85% or something like that. I think the class average in the other class was a 78. There's an online section that also, some of you are in that section and come to class physically. So we actually have two sections of classes that are either online here or sitting in this room. So really, all in all, the exams were actually pretty decent. So if you did substantially worse than that, ask yourself some questions as to why you didn't do well. And, you know, if it's lack of effort and things like that, well, then you can fix it for the final. If it's that this stuff's just not for you, you know, have that discussion with yourself and decide if that's true. One thing that it was nice to see is have been several students over the first 8 weeks that have come to me and said, oh, this stuff's just not clicking or whatever. And lately they've been doing pretty well in the homework, and then they did well in the exam. So, you know, adds a little credence to, you just keep throwing time at it. Well, more than 6 hours, obviously, but, you know, some legitimate time at your homework, and maybe you'll do, you know, you'll come through in the end and do better. But I would say if you got like a 50% or lower, you really want to look at that and find out, decide for yourself why that happened. All right, so homework. Let's see, write a function that fills an array up with 10 integers ranging from 1 to 10 and does not return a value, but turns back control to main. Okay, well, let's do that part first. All right, so we are going to write a function that fills an array up with the values ranging from 1 to 10, but does not return a value. This goes down to what we were talking about in class last time about the idea of pass by value versus pass by reference. All right, so okay. Well, I'll just use this blank slate. All right, so we're going to call this guy, it's going to be void. We're going to call that guy fill array. And for right now, I'm going to put a couple question marks here as to what the parameter is going to be. Okay, but it's going to be called fill array, and the job of this guy will be to take in an integer array, fill it up with the numbers 1 through 10, and then not return the value, presuming that the array has been stored. All right, I'm going to actually give myself another. Did I ask you to do a print array or something? Display those values. Yeah, so that's going to be the way we prove that it worked. All right, so inside of main here, we might go ahead and create a maybe an int array called AR that's capable of holding 10 things, right? Okay. And then we're going to write this array, write this function. What should my parameter be for a function that's going to take in an integer array? Okay, well, we might be interested in the number of elements in it. In this case, you could have probably assumed 10, but you're right. We could have taken in the number of elements because we mentioned last time that our arrays in C++ do not know how many values are stored. Okay, so we could pass in the size of it. What about the array itself? What's the data type of an array? If we're passing it into a function and we want to make changes to it and have those changes be permanent. Go ahead. Okay, it's a pointer. What kind of pointer? What kind of value points to the beginning of the array? Okay, well, sure. But this is an integer array, so it's going to be an int pointer, right? So we can call that guy here. We'll call it the array. And then we can go ahead and put in size as well. As he pointed out, this would make it work for any size array, not just size 10. All right, and we want to go ahead and we want to fill this guy up with the values between 1 and 10. So we'll say for int I is equal to, what's the very first element of the array? What's the position in the array of the very first element? 0. So arrays are 0 indexed, just like strings. So we'll start I off at 0. We'll keep going as long as I is less than size, the number of elements in there. Or if you decided to keep it to just hard code it at 10, you would say less than 10. I probably like the size solution better, but it wasn't required. And then each time through, we're going to say I is equal to I plus 1. Remind me after I do this, I want to talk about the I plus plus thing. I haven't talked about that in here yet, right? Several of you are using it, but it's actually an important concept because you probably, at least many of you, don't really realize what it's doing as much as you could. So that's why I purposely keep saying I equals I plus 1. We'll talk about that in a minute. All right, so we're going to go through all the indexes of I, 0 through size minus 1. And each time through, we're going to say the array at bucket I gets the value of, what did I say, 1 through 10? Is that what I said to fill it with? 1 through 10. So technically, we're going to fill it with I plus 1. So the array at bucket 0 gets a 1. The array at bucket 1 gets a 2, so on and so forth. So it's 1 greater than the index. Okay, so that should fill up the array. And this guy's going to take in a int pointer. One interesting thing is you can actually write your prototypes like that, if you've seen any examples online. So even though down here I actually gave variable names to my parameters for when I actually implemented the function, when you prototype the function, you don't actually have to give it the variable name since you're not implementing it yet. You can just say this function expects you to pass in an integer pointer and an int. I always write it with the variable names in it, but technically you don't have to, because the job of that prototype is to just let main know that you may see me call a function named fill array, and I promise you I'll implement it later, but these are the rules that it plays by. Make sense? All right. So we'll go ahead and we will call our fill array, passing it AR and passing it 10. We want to be a little bit more generic here. We'll say something like array size is equal to 10. And then we'll change that guy to array size and this guy to array size. You know, that way, if I want to change this up to hold 100 elements, I just change it there. And now I create an array that holds 100. I pass in an array that holds 100, so on and so forth. All right, so that should fill this array up with zeros, well, with 1 through the size. All right, now I want to look at something interesting here real quick. I'm going to go ahead and do a cout AR. All right, now right now when I call fill array, what will this output to the screen? Nothing. So I'm going to call it. It's not going to be a problem, but we're not going to see the results of it. So what are we going to actually see this program output? All programs begin and end with main. So what are we going to see this guy output? Yeah, a memory address. The value that is AR. And AR is an array, so it holds the value of the base address of AR. So AR is an array capable of holding, in this case, well, I have it currently set at 100, but in this case, 10 integers, right? And the value of AR is the address of the very first integer. And we talked about how arrays need to be organized in contiguous memory. So we need to, once we know where the beginning of it is, we can take integer size steps through memory to get to the next values. All right. So we should see a memory address here. There's our memory address. All right. So now we also want to have a function called display array. And this guy will also take in an int pointer called the array. And we'll also have it take in the size, so we can pass it any integer array of any size as long as we advertise to it, and it'll go through and display them. Okay. And we're going to have a very, very, very similar for loop here. So for its I is equal to 0, I is less than size, I is equal to I plus 1. And we're going to go ahead and just output the array at bucket I. And what I'm going to do, just so we can see it a little bit easier, I'm just going to add a space to that. So it'll have a number followed by space, then a number followed by space. That way it all is on kind of one line. And then what I'll do afterwards, I'll kick it down a line after that loop's done. Just so we don't have a wall of numbers. We have a wall that goes horizontally a little bit rather than just number after number after number. A little bit easier for us to read. So we'll go ahead and call that guy. All right, so what's our output going to be this time? So fill array takes in a pointer to the beginning of our array, as well as a number of elements in it, goes through all the indexes, sets each index I of my array equal to the current value I plus 1. So that'll fill it up. Display array then takes in the array, the size, goes through all the indexes, and prints out each number followed by a space, and then kicks it down a line afterwards. So what's the output of this program going to be? Oh, I put a period here. So there's my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think that answers the homework. Yep. So we have one function that fills the array, but does not return a value. That's this function right here. Fill array does not return a value. So we passed it the pointer, the memory address of that array, so that when we made changes to it, those changes were globally felt. There was side effect. That's what we talked about last class. Second part of it is it should then call another function that displays those values in reverse. Oh, I said in reverse. Sorry. Display in reverse. So this will be size minus 1. Keep going as long as I is greater than or equal to 0. I is equal to I minus 1. So now it displays it in reverse by accessing the elements of the array. Okay. Now it solves the homework. Questions about that? So those are the two functions to write. What was the magic here? The real thing that we wanted to get out of this is reinforcing the idea that when we create an array like this, it is stored, we get a memory address. We printed that out right here, proving that we got a place in memory where that array lives. All right. And if we were interested, here, let me just show you something real quick here. If I do a cout the address of AR, I'm going to say at bucket 2. All right. So if AR is the base address of our array, AR at bucket 2 means we had to take 2 integer size steps through memory to get to the element at bucket 2. And what does this little ampersand here mean? What does that say do? Remember, we have 2 syntaxes when we work with pointers. We have the asterisk, which says give us the value at that memory address. What does the ampersand mean? Give me the memory address where this dude is, right? So I'm saying, hey, give me the number that lives at AR at bucket 2. Okay, even though we haven't actually put a number in there yet, so maybe we'll fill it real quick. Beginning. So give me the number that lives at AR at bucket 2, but then specifically tell me where is that stored. And what we should see is it is stored 2 32-bit or 4-byte steps to the right of that base address. Go ahead.
Why did you put the AR bucket 2?
It's possible it wouldn't have required it because this just comes down to a number. I think it just made it look a little bit better because what I'm basically saying is I want the address of what you found here. And actually, even as I'm writing that, I wonder if that's going to work. Because that is going to boil down to a number. So then it's going to say, what's the address of that number? So I actually might need to write that a little bit differently, but, you know, let's see what we get. No, it figured it out for me. All right. So this actually made it very nice since I had a 0 base starting value. So, you know, first number was that 600. Forget about the rest of the stuff after that. Then when I take 2 4-byte steps, I end up at 608, right? And that's what this memory address is. That's the memory address of the second element, effectively proving to us that it is contiguous memory, at the very least. The second element is 2 integer-sized steps away from the first element, which maybe lends us to think it's probably in contiguous memory unless we like hit the lottery or something. All right, that makes some sense. Oh, another friendly one. We're getting some good addresses there. All right, so fill array took in a pointer to where that array lived, not the value of the array, the pointer of that array, so that when it made changes up in real memory. It also took in how many elements are in the array because arrays don't know how to advertise the number of elements that are in them. In newer languages, they do. So when we look at Java and C#, arrays in those languages, we can ask the array, what's your length? And it'll tell us, so it's 10 or it's 100 or whatever. All right, here's just us doing some printing out stuff showing that how arrays are actually memory addresses and contiguous memory stuff. So we fill it here with all the numbers between 1 and the size of the array. Here we're displaying it. Again, we pass in a pointer to the array. We pass in the number of elements in the array, and it goes through and displays them. Understand that the scope of AR is right there in main. So that was one of the questions on the exam, right? What's scope? Scope is where a variable is accessible, which means that AR here is only directly accessible from line 19 to the end of main here. It means it is not directly accessible in here. It is not directly accessible in here. How did we get it into those places? We had to pass it as a parameter. We let fill array know about the pointer, where in memory this array lives. We let display array know about the pointer, where in memory that the array lives. I happen to name those variables in those functions the array for no good reason. Historically, when we were really talking about scope a lot, I would have purposely named them AR to drive home that point that these are different ARs, even though they have the same name. In this case, I just named them something different. All right, so when we're talking about the array in here, if I do a cout the array, and I do a cout the array here, you're going to see that we get the same memory address. I'll just get rid of that second line there. So we'll go ahead and we'll define the array, we'll print out its memory address, then we'll call fill array and ask the very first line of fill array will also print out the value of the array, which will be the same memory address, proving that we passed the memory address in. And when we actually call display array, the very first thing we'll do is also display the current memory address. So we see we get the same memory address 3 times. The original in main, and then how we pass that address to the 2 functions. And now if we want to have 1,000 numbers, we don't have to change anything except that. Now we have 1,000 numbers printed in reverse. All right, questions about that?
So I didn't use it pointer. Why did that?
What do you mean you didn't use a pointer? So instead, for display array and fill array, did you say this? That's how you wrote it? That is a pointer.
Oh.
Yeah. But it's a good question. So she wrote the parameter here as an int array called the array. Arrays are pointers. We saw it right here, right? When we defined the array here, and then we printed the value out immediately afterwards, we saw a memory address. So it is a pointer by definition. You didn't have to use the special syntax, but you effectively are using the so you told fill array to expect an integer array to be passed in. And integer arrays are passed by address by definition. I would probably say that using this syntax is probably going to benefit you for times when you're not working with collections. Instead, you're working with just numbers. So really driving home that that point of the special syntax for pointers, I think has some value. Although what's interesting about even that statement is that as soon as you get to a language like Java, the syntax for pointers goes away. And if you were writing this function in Java, you would have said int array the array. A very similar syntax to what you used is what would be the correct syntax in Java, because we no longer have the asterisk-y and the ampersand thing. No. Well, it still worked, right? But it's actually a little bit of an interesting thing, even comparing the languages. In Java, you say int array, the array. I actually prefer this syntax in that this is the type, just like all variables, right? We have the type followed by the variable name. The type of this variable is an int array. I don't like the C++ and the C syntax of that, where you put the brackets after the variable name. Just seems inconsistent to me. If the syntax for a variable is type followed by variable name, why does this guy sneak the type part of the type into the variable name? I just don't like it, but it works. It's fine. In fact, actually, in a newer version of C++, possibly even this one, it's possible that syntax will work. Let's actually see. Nope. Not happy. So, nope. It still ticks me off. So, all right. But that syntax uses our, asterisks and ampersand stuff, which is fine. But if you got it working and you're passing around addresses, that's the point of the assignment, right? To practice around with side effect and things like that. All right. Other questions on this guy? Why does it hate me? And that's the reason why you have to spend more than 6 hours in your homework. Well, I mean, the thing is, so fine. We did this in class, and I was babbling about all sorts of stuff while we were doing it. It didn't take very long, right? It didn't take 6 hours to write. Okay. But I didn't make very many mistakes when I was writing it, where he might spend 2 hours looking for the one little mistake he made and then realize that, okay, that's 2 hours of my life I'm never going to get back. But during that 2 hours of hunting for the bug, he learned about a pattern that he has. Maybe he forgot a semicolon, or maybe you put a semicolon at the end of the for loop, or you had a semicolon at the end of your function. I think I mentioned that last time, that when you copy it from up here, if you copy the whole thing and you have the semicolon come with it, you might hurt yourself when you paste it in and forget to take it away. You start noticing patterns from yourself, and then over time, you'll start making less of those syntax errors. All right, make some sense? Okay. So now let's do, you got it? Nailed it?
Plus signs.
Oh, well, so in some ways that's my fault, because you copied it the first way. This one, you copied the first thing I wrote where I hadn't read that it needed to be in reverse. Yeah, right. So I'll take a little bit of the blame for that, because when I did the homework for you, I did it in parts and didn't read the whole second part. Which means that if you print your stuff out forward instead of reverse, not only do you get a 0 on this, you get a 0 on the next assignment. It's a double whammy. I don't make the rules. So on the homework, if you did everything right, except you printed it forwards instead of reverse, I won't take off points, since I did it too. All right. So let's let me save that. Homework. We said this is homework 10. Let's just go with that. All right, so I pasted the link to that in Slack. All right, so let's keep going here and talk about some other fun stuff. I think it is. Let me quickly get the syntax for random numbers in C++. Pretty sure it's just randint, but or rand. And that is in standard lib. All right. Let me just put these couple things in, then I'll explain what's happening here. Okay. We got it. So we're gonna just do some random number generating stuff here. So I'm gonna say for int I is equal to 0, I is less than 10, I equals I plus 1. Oh, and that reminds me, I need to talk about the plus stuff. So actually, let's just do that real quick here. All right. So we're talking about plus and minus. These are the let's see. Plus is the increment operator. Adds 1 to the calling value. Minus is the decrement operator. Subtracts 1. From the calling value. All right. Now, this, there's 2 minuses. It just didn't put a space in there. It thinks it's smart by melding them together. Can I do a space and then backspace? Ta-da! All right. So proud of myself. Oh man, so good. All right, so many people know about these. Very few actually know all the rules. So, for example, if I say int a is equal to 5, and I say cout a, we're going to get a 5, right? What if I say cout a plus plus? What's going to print? Again, a 5. All right. So we still got, oh, what did I do? What did I do? Oh, look at that. See, I was doing it to trick him. See, whenever I make mistakes, I always do it on purpose. It's usually at one of these two guys' expenses. All right. So we see we got 5 both times. What if I said plus plus a? Now we'll get the 6. All right. So that operator, that plus plus operator, can be used before or after the variable. If it's used before the variable, when you call it, you immediately get the value, the updated value. When it's used after the variable, you get the current value in the moment. So for instance, when I said a plus plus, we saw that it was still a 5. Yet if I were to print it out on the next line, we'll see that it did change into a 6. So a is 5, we print it out, it's 5. We print out a plus plus, it's still printed out a 5, but we see that the after effect of it was that it did become a 6. But because we had the plus plus following the a, it happened after we got the value. If we had it before the a, then it does the update before we get the value. So now we'll have 5, 6, 6. Make sense? The minus minus operators work the same way. But now one thing I'll tell you is, while I think it is good that you understand this, so that when you're looking at code examples, you understand what's happening, a lot of times what you'll find is people will just use the plus plus beforehand all the time, because what they almost always mean to get the new value immediately. And they've trained themselves that the way to do that is to put the plus plus beforehand, but they don't necessarily know why it behaves differently. Good rule of thumb, similar to like when I say for if statements, always use the opening and closing curly braces, is if you're going to modify the value of a variable, do it on its own line. So if I say a plus plus right here, and then I print out a on the next line, it will be a 6. So a prints out a 5, a plus plus, fine, the a is the 5 currently, but it becomes a plus plus. I don't do anything with it other than increment it. Now it's a 6. Which is going to give me the identical result if I say plus plus a there. I'm not relying on the knowledge of what happens differently between having the plus plus or the minus minus before or after the variable by putting on its own line. Okay, I encourage you, to know this little, I don't know, piece of information, I guess, about whether it happens before or after the variable. But in your programming practice, unless there's a really good reason that you're embedding it inside of a line, which every now and then there's some, funny little problem you're solving where you actually want the current value, but you also want it to change after this, and it's inconvenient to put it on separate lines or something like that. Every now and then it might be helpful. But let's call it 99.9% of the time, when you're updating a variable, you probably just want it to be one more than it used to be, and you really want it right now. Just do it on its own line, then you don't have to worry about which of the two syntaxes you use, whether you put it before or you put it after. Make some sense? make you less error prone. Nobody's impressed if you embed the counter inside of there. Because now this is going to give me a 5 here. 5 becomes 6. It'll print out a 6, which then becomes a 7. It'll print out a 7. So being able to read somebody else's example code, where when you're looking online, you will find lots and lots and lots of programs where you'll see either the plus plus after or the plus plus before, knowing that those are actually different and could, in context, have a different, make a difference, is important to know. But that's the scoop. So any questions about the plus plus and minus minus stuff? If you want to just replace all these with minus minuses, you'll see it just goes the other direction. So this will be a 5. 5 will become 4, so this will be a 4, which then becomes 3, so that'll be a 3. All right. So now we're allowed to use the plus plus and the minus minus stuff in our loops, because it is kind of, when I have to go out of my way to write it the other way, it gets frustrating. Well, let me ask you something else. What about if I say a plus 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 plus? Go ahead. I think it's 2. This is one of those examples. One of the things I've mentioned several times is this idea that sometimes at a glance, you think code means one thing, but you really have to slow down and think, what does this resolve to? If A started off as a 5, A plus plus will ultimately boil down to a 6, right? When all is said and done. So then the question is what does 6 plus plus mean? It's no longer operating on that variable. Now it's saying 6, you are now something new, I guess. I promise you they're not going to let you reinvent numbers in the language, right? So saying a plus 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 doesn't make any sense, because at the very beginning of that, this guy here will resolve to a 6. And now you're saying increment a, what's usually called a literal value. So if I just have a number, like the number 7, that is an integer literal. A, that is a char literal. Hello, string literal, with a little extra swoosh there at the beginning. Make sense? So whenever you hear somebody talk about literals, it's a hard-coded value, effectively. Okay? And hard-coded values that are built into the language, you're not gonna, it's written in permanent ink. You can't go and make changes to numbers. 7's gonna always be a 7. All right. So now, let's add that. There is a difference between the operator coming before or after the variable. Comes before the variable, the value is immediately immediately changed, and you have access to the new value. If it comes after the variable, the value is resolved first, and then it is changed for future use. Something along those lines. You think about like an exam or something like that. I'm sure I'll mention this again when we go over the final exam, but this would be fair game, but probably not a high priority question, because I kind of teach from the perspective of really the way you should use these, it should never actually make a difference. whether you put it before or after, because it should always be on its own line. So you don't have to rely on you knowing about this piece of information. Really, this group is at a disadvantage because when you're looking at, well, all, beginning programmers in the last, call it 15 years are at a disadvantage because a lot of times you're looking at code examples from a much older programmer where it used to be cool to write your code as concisely as possible, where you would embed ++A or A++ into your code. And then it really did make a difference, whether or not it came before or after the variable. And sometimes you're stuck looking at those examples. And if you don't know what it means, then it can be problematic because you might wonder, why does this work this way? Not understanding that there is a difference, whether it comes before or after. But I think that anytime you can make a choice in your programming to make you less error prone, it's a benefit. All right. So now, what was I about to do? It's about to, random numbers. That's right. Let's get rid of all that stuff. It's just in the way. That way we don't get the warning. All right, so we are going to, we're learning about random number generating. So I'm going to say cout rand. I'll go ahead and kick it down a line. All right, so there is some random numbers. Oh, interesting. Does it only give me positive numbers? It does. Fun. Okay. So we see some big numbers there, right? Based on what you see there, what guess would you make about the kind of value that the rand function outputs? First of all, we see 0 negative numbers, right? So what's likely the smallest value that it will output? A 0. What do you think is the largest value will output? Well, a lot of those numbers are bigger than 9. Like way, way, way bigger than 9. In fact, we don't have any numbers less than 9. So let's try that again. What would you guess is the largest value this guy's going to output? What's the maximum size? What's the maximum value for an integer?
2.1 billion.
Yeah, the 2.1 billion guy. So this, my best guess here is this will output a number between 0 and 2.1 billion. There's a possibility, we can test it here real quick, that it might output a value between 0 and 4.2 billion, because it might say, oh, well, we're gonna do unsigned integers. Therefore, you get the entire 32-bit space for an integer to hold all the positive numbers. You no longer have to use one of the bits for the negative side of things. That's possible. It's more possible in C++ than it would be in a newer language. C++ does allow you to create a variable of type unsigned, where that's never done anymore. So that's why I don't show it. But it is possible if we, here, let's just do 10,000 numbers. If, so we're going to do, we'll call this int temp. We'll say temp is equal to rand. Then we'll ask the question if temp is greater than, let's see, that's 2.1 million. That's 21 million, 210 million, 2.1 billion, right? So that's 1,000, million, 10 million, 100 million, 2.1 billion. Right. So I'm just going to generate 10,000 random numbers, presuming that somewhere in there we're going to get, if there was a number bigger than 2.1 billion, there actually is some change here. So if I really want to be 2 to the 31st, that's actually the number. 2,147, 483, 47, 483, 648. And I'm going to say 647, given that I think this is my guess is it's using signed numbers. So the negative, it's negative 2.147483648 to positive 2.147483647 on the positive side. So we're looking, does it give me anything bigger than that? That'll let me know whether it's allowing us to go past the maximum positive number for a 32-bit signed integer. So we're hoping out of 10,000 we get some number that would be in there. I'm guessing we won't. We didn't. There, let's do 1,000,000. Also didn't. All right. I'm going to say we've thoroughly tested it, and the largest value it will give you is positive 2.1 billion. Maximum size of a signed integer. Okay. So now that we did that experiment, we probably could have looked that up too, but it's more fun to experiment with it ourselves because it helps us understand the tool we're using, right? All right. Now, one thing I want to show you here, though, I'm going to create 10 numbers. Oh, hold on. Well, actually, it didn't make a difference. Technically, I would have said I was going to print out temp here, but we never got into the if statement anyway, so we still proved the right thing. All right, so I'll go ahead and I'm just going to give myself 10 and 10 positive numbers. Okay, so look at this last number here. 118,964,1421. Is that the same number? Still the same number? What are the odds? Still the same number? Probably not what we want when we're generating random numbers. Now, I will tell you this. It actually is. I can make an argument why this could be helpful in that if you are writing a program that relies on some random numbers, but you're having like a weird bug, always having the same set of numbers you're working with kind of helps you maybe dive into it. Once you have it solved, then you really do want them to be randomy, right? When you run the program multiple times, you get different values each time. So it's that there's actually, you could teach a whole class on true sources of randomness. Creating random numbers is actually very difficult. So we always call these pseudo random numbers. There's all sorts of different approaches to how they get these. But what we do is we can seed the random number generator. So we use a function called srand that seeds the random number generator, and we use time null. So now this is 960 there. We see we get a different value this time, yada, yada, yada. All right, so what is this actually doing? I am seeding the random number generator with the current time. And I think the default current time, when I say null, it just says give me the default one, I think goes down to milliseconds. So every single time I call this, as long as I don't call it twice during the same millisecond, I'm going to get a different seed value, which should produce a different range of values. Make sense? So if you want real random stuff in this, you'll say srand to seed it. We had to do a couple of new things here to include these functions. We brought in another library. Before we were using IOStream. IOStream allowed us to use the cout, right? That's why we use that namespace standard here. If you didn't use the namespace standard, you would have had to use a syntax like that, standard cout, to get it to know where you were talking about that cout function. So that's the rationale why we put using namespace standard up here, to avoid having to write this extra thing there. But now we want to have some other tools available to us that are built into the language just in different libraries, because it seems reasonable that we might want random numbers. Okay. Now, one thing I might say about this though is, don't assume that, well, you pretty much could assume that things that I ask you to write as homework assignments are very likely not built into the language. Sometimes they are, like converting numbers between bases. That's actually usually built into a language. But I'm almost never asking you to use the thing built into the language. Typically it's, I want you to write this first, then I'll show you the easy way of doing it by using the thing built into the language. In this case, generating random numbers, I just mentioned that pseudo-random numbers are difficult to come up with. So rather than ask us to invent our own little way of coming up with random numbers, we're just going to use the built-in random number thing. And that means we had to bring in two different libraries. One is standard lib. Okay, and standard library has in it the rand function, which we saw generates positive random numbers in the range of positive integers, 0 to 2.1 billion. And then we've seen this second function called srand, which takes in a number to seed the random number generator. All right. We can choose what integer to give this for the random number generator, so we don't have to use time to do it. But we don't have a much better option available to us. So we want to use the millisecond hand on the clock to get different random numbers. A lot of times this is done as what's called an epoch. Anybody seen that word before related to programming? Is that like thunder, or is that like a crash into the loading dock?
Yeah, it's quite a bit.
Isn't it snowing today? Is that thunder snow? Fun. So have any of you ever seen this little word epoch as it relates to programming stuff? It's possible we're distancing ourselves enough from old school computer science where you may not actually run into this in the wild. But most of our clocks today, when you use a time library in any programming language, even modern libraries, they use something called an epoch, which is the number of milliseconds since Jan 1st, 1970. Which is a lot of milliseconds, right? But we can hold really big numbers. So it ends up working out. Eventually, this will be like the new Y2K bug, when epoch no longer makes sense because we're off the end of, because they're probably represented as a long. So this is that 9.8 quintillion number. Remember that one? Really been, there hasn't been 9.8 quintillion milliseconds since 1970. We could do the math, but we'll find out it's south of that. So that's why that will work. But that's usually called the epoch. I'm not going to test you on that. Just something you can throw in your little data bank somewhere. You might bump into it at some point. All right. So we had to bring two libraries in for us here in order to have access to the stuff we need to generate real randomish numbers. All right. Questions on that? All right. So now, having said, you're wondering, when do we actually?
There's a clock.
Yeah, you can do the math. Does it tell you what's the date?
Well, it doesn't tell you the date. It tells you how many there are right now, but it doesn't tell you.
Oh, yeah. Well, maybe that's your homework assignment, is do the math for what's the calendar date when the epoch breaks. I bet you it's still pretty far in the future. I don't think it matters. I think it's going to be one of those things where it's still probably thousands of years in the future.
This is January 19th, 2030.
Really? Oh man, that's kind of scary. Well, we better hope we're onto a new computing system before then. 1938?
2000.
Oh, yeah, that's right. 2038. 1938. Doesn't even make sense.
I gotta write a book.
I mean, it actually, well, you know what? It actually won't. Trust me, this keeps us on computer science. Let me show you something neat. It's quite telling about how this stuff works. So it's right in line with what I usually do. So I'm going to go ahead and create a byte B is equal to a 0. Actually, I'll just do this inside of a loop. So let me comment this stuff out. So this will be another one of those things where I show you some code and tell you to tell me what the output is for byte B. It's equal to 0. Actually, we're just going to do a infinite loop. While true, let me delete all this. No. All right, we'll start this off at 0. So we're going to do a C out B. And then we'll do B is equal to B plus 1, because I don't think the plus plus operator is defined for bytes, just integers and longs. It might be, but let's just roll with this. Doesn't matter for my example here. So I'm going to start a variable B off at 0. And remember, bytes, these are 8-bit signed integers. So the range of values is -128 to +127. All right. So I'm going to say do this forever. I'm going to say print out the current value of B, which is 0. 0 becomes 1. Spin back up. Is true still true? It's going to be true for a while. All right. So now we're going to print out a 1. 1 becomes 2. Print out a 2. What's the output of this program going to be? Really, I'm asking is what happens when you get to 127 and then you add 1 to it? What's the next value? -128. So you'll actually see that it continues to wrap. Byte's not declared. But I told them that was a legal primitive type. Oh, look, standard byte is only available in C++17 onwards.
Time to spend 6 hours, huh?
I know. I'm going to cheat. I'm going to cheat.
It's not even letting you cheat.
Yes, it will. Well, you told me I had to use C++17 or newer. Well, it should already have that namespace. Oh, I can't even use the plus operator for bytes. That's fun. It seems like it's giving me a different error then, though. Yeah, I think we're still okay. We're just doing a little fakesy stuff. There we go. All right, so I'm gonna go ahead and stop it. Oh, can I not see it? All right. Let's see. Well, here, let's just do this. We'll do it 1,000 times. That'll show enough for me to prove the point. All right. Oh, wait a minute. It is going higher because it's an int. All right, fine, fine. So we'll prove the point with integers. If I need to make this that 2.1. What is that? 2 to the 31st. Two 147,483. 147,483. 647. 647. Get rid of our loop. See out temp. Temp plus plus. There we go. All right. I wasn't going to run a loop for 2.1 billion times. So I just set temp equal to the very largest positive integer that it can hold. I printed it out. So there's that. Then I added 1 to that guy. And we see that it wraps around to the smallest integer on the negative side, which means that I can count using integers as well as all the other types, including bytes, by always adding 1 to it. And this isn't something special with the programming language. This is how binary numbers work. Because what ends up happening is if I have the byte 127, the signed byte 127, and I add 1 to it, what ends up happening is since only 7 of the 8 characters or 7 of the 8 bits are used for magnitude, when I add 1 to it, it actually causes the thing to wrap around. So it'll end up being 1, 1, 1, 1, 1, 1, 1, which is negative 128. And then you keep adding to it. So the math works out. It's not some if statement that just said, oh, well, if you go too big, let's just set it to the smallest value. The bitwise math works this way. All right. So there's that trivia thing. So right now we're printing out 10 numbers in the range of, get rid of this guy, integers. Now, what if I want to have numbers between 1 and 10? How do I accomplish that? Using only what we know so far. And we've known it for a while. Just string. We have a rationale. We're just throwing terms out. Third grade math. Okay, and we've worked with modulus, right? All right, so if I want a number between 1 and 10, what do I mod it by to get the remainders that will give me something, let's call it close to that range? If I mod it by 10, what are the range of values I get? 0 to 9? How do I make that 1 to 10? Add 1 to it. Problem solved. All right, so I can say temp is equal to, actually, I don't even need to do it there. I could say rand mod 10 plus 1. And now that'll give me values between 1 and 10. Make sense? All right, so last homework was too easy.
He was just kidding.
Oh, I don't even need you to write a function. Well, for that, you will write a function. Fill an array with random numbers between 1 and 100. Array with, let's call it 50 random numbers between 1 and 100. Write a function that can display the contents of this array. We basically wrote that as part of today's homework, right? Just pass it an array, show me what's in it. All right. Write another function called sort array that takes an int pointer as a parameter. That is a pointer to the array. And returns nothing. But it should leave the array in a sorted state from smallest to largest. You could only use tools we have already learned in class. As you might imagine, there are sorting functions already built into the language. So effectively, what we're doing here, and I'm going to be showing you some better sorts. And if you stumble upon one of them as part of you trying to figure out how to do this, that's okay. But effectively, what I'm doing is I'm saying, look, here's a pile of numbers that are out of order. I want you to write the code that gets them in order somehow. And really what I want you to do is I want you to think about this like what you would do as in real life. So if I gave you, you know, a whole bunch of, let's say, poker chips with numbers on it, laying in front of you, a big pile, right? And I wanted you to put it in order from smallest to largest. What might you do? You might start off by saying, well, I'm going to just go through here. I'm going to find the smallest value, right? I'll put that at bucket 0. Then I'm going to go and I'm going to find the next smallest value. Put that at bucket 1. I'm going to go and find the next smallest value. Make sense? So if you want to approach it differently than that, that's okay. But what I'm really trying to drive home here is most of us are able to solve these problems in real life without too much trouble. That would be a tedious problem to solve, but we could do it. I'm asking you now to convert your real life problem solving into some code. Then we'll look at some better algorithms for doing this, because there's plenty of sorting algorithms that we're going to look at. We're going to look at a couple of different ones, but you know, for right now, I want you to focus on trying to figure it out yourself. And if your solution happens to kind of stumble near one of the known algorithms, that's okay. But the challenge really is I want you to kind of almost like brute force this, but in code. Make some sense? All right, so I'm going to give you the current code as a starting point.
Use the standard lib and time input.
Yeah, everything I've shown you so far. Yeah, but that means no sorting. No, you can't use whatever. I don't know where it's at. It might be in standard lib. There's definitely functions called sort or whatever that will do it for you, but you're not allowed to use those.
Yes, and I'm gonna have.
And if you don't spend at least 20 hours in this assignment, you're doing it wrong.
Or I'm just doing it too right. Or you're just that good of a teacher.
No, it should only take well, I would have thought the last assignment should have only taken you maybe 2 or 3 hours. So, I mean, you're right. 6 is pretty pathetic. No, it's all good. This one shouldn't take any longer.
No.
Because the other one wouldn't take you 6 hours to do now, right?
Yeah.
You understand it better now.
Now that I actually know how the array and I think I understand how this one is gonna be done. Now that I have the random,
Okay,
randomly assign numbers into it. How I connect the random numbers assigned to the array. That's how I'm gonna sort it. There's a bunch of if statements that kind of sucks.